Good afternoon, dear colleagues. Today, I want to talk about something that lies at the very heart of architecture and design, about form, but not simply about form as an external outline, but about form as a dialogue between the artist and the material, between the concept and the law of nature, between art and science. In the mid 20th century, Charles Percy Snow formulated a problem that unfortunately has not lost its relevance today. He spoke of the tragic divide between the two cultures, the sciences and the humanities. Physicists and poets stopped understanding each other. In education, this led to fragmented thinking. The engineer does not see the beauty, and the artist does not understand structure. The response to this challenge became the STEAM approach, where the letter A, arts, occupies an equal position with science and technology. And I want to demonstrate to you that for architecture and design, this synthesis is not merely desirable, but is embedded in their very nature. What do we talk about in our profession? About form, space, material, light, structure. But what is form? It is an object of aesthetic experience, yet simultaneously it obeys the laws of statics and mechanics. We sense space intuitively, but geometry describes it. Material inspires us with its texture, yet dictates its physical and chemical properties. As Kenneth Frampton amply noted, architecture always balances between the freedom of artistic expression and the rigid necessity of constructive logic. And if this is so, then architectural education itself can become that ideal laboratory where the gap between the two cultures is overcome. Our goal is to form a new type of professional, capable of seeing in every object the result of a dialogue between art, technology, and science. It is important to understand this idea was not born today. History knows remarkable examples of such unity. Let us recall Leonardo da Vinci, the universal man of the Renaissance. For him, there was no boundary between artistic practice and scientific inquiry. His genius paintings, the Mona Lisa, the Last Supper, became precisely possible because Leonardo meticulously studied anatomy to convey the plasticity of the body, explored geology and hydrodynamics to make landscapes breathe with realism, and mastered optics so that space in his paintings acquired depth. He wrote that whoever criticizes paintings for imitating nature criticizes nature itself and the creative force that acts according to its laws. Later, in the 18th and 19th century, Goethe proposed his own path. In polemic with Newton's physics, he created his theory of colors. Not so much a physical explanation as an investigation of how humans perceive color, how light and darkness meet at the boundary, giving rise to chromatic diversity. This was a phenomenological approach, demonstrating that sensory experience and reason can approach truth through different yet equally valid paths. But the true fundamental breakthrough came in 1917 from the Scottish biologist Darcy Thompson. In his treatise on growth and form, he showed that the entire infinite diversity of natural forms, from the spiral of a shell to the curvature of a bone, could be described in the language of mathematics, physics, and mechanics. His famous phrase became a manifesto. In the last analysis, form is a function of force. The beauty and the purposefulness of nature are not a miracle, but a direct consequence of objective laws. This idea became the cornerstone of all subsequent development in architecture and design. But how do we move from general words to concrete pedagogy? What bridges connect science and creativity? I will highlight four key categories. The first bridge is biomorphology. This is not about building structures shaped like flowers or shells. That is a dead-end path of imitation. True synthesis begins where we analyze the principles of nature, branching as a way to distribute loads, porosity, and cellularity as a way to ensure strength with minimal weight, minimal surfaces as a way to conserve material. As Janice Benes says, nature doesn't reinvent the wheel. It has been refining solutions for 3.8 billion years. The second bridge is physics of materials. Every form exists in a gravitational field, experiences loads, and reacts to heat and cold. Understanding strength, elasticity, thermal conductivity transforms working with material from a craft into meaningful design. In this sense, form is the visualization of internal forces, the bending of a beam, the sagging of a membrane, the thrust of a vault. These are not accidents, but an honest dialogue with physics. Finally, the third bridge is geometry and symmetry. Mathematics gives us the language to describe harmony. Herman Weyl wrote that symmetry is the idea through which humanity has for centuries attempted to comprehend and create order and beauty, from the golden ratio in classical orders to fractal algorithms. In contemporary parametrics, mathematical regularities remain the framework that connect logic with sensory perception. And now, finally, the fourth bridge is environmental sustainability. Today, ecology is not a set of technical requirements, but a powerful generator of form. Questions of energy efficiency, waste minimalization, adaptability to climate become the challenges to which form provides an optimized answer. These conceptual bridges are at work today in real design practice. Take biomimicry. The famous Eastgate Center in Harare by architect Mick Pierce. It has no air conditioning, yet maintains a comfortable temperature. The secret is that its ventilation system is copied from termite mounds, an engineering marvel created by evolution. Another dimension is parametric design. The architect, like a scientist, defines not a rigid form, but a system of variables and an algorithm. Form becomes a process of computed responses to a multitude of conditions. The Haidar Aliyev Center in Baku by Zaha Hadid is a striking example of such fluid, mathematically calibrated geometry. And thanks to digital manufacturing and new materials, these complex forms can be brought into life. 3D printed concrete, shape memory materials, and aerogels. All of this blurs the line between concept and realization. As Neri Oxman says, the materials of the future will be like biological tissues, where function and form are inseparable. But how do we teach all of this? How do we restructure the educational process? In drawing and sculpture, we must move from simple copying of nature to structural analysis. The students should see in a shell or a bone not only a beautiful form, but an engineering system where every curve and thickening is functionally justified. In art history, it is important to show how scientific discoveries change visual language. Crystallography and Malevich's suprematism, the theory of relativity and the multidimensionality of cubism, chaos theory, and the fractal architecture of our day. These are not random coincidences, but a deep connection. In design studio, ecology and material science become not tedious regulations, but sources of creative ideas. Life cycle assessment tools, the principles of circular economy, these are challenges to which form must find an expressive answer. What is our ultimate goal? To form what might be called synthesize or synthetic thinking. This is the ability of one holistic gaze to see in a sculpture a diagram of forces, in a historical monument the imprint of a scientific worldview, in a building's facade a climate machine, and in a natural landscape a perfect structural logic. As Shashenkov precisely formulated it, architectural form is a materialized dialogue between cultural memory, physical laws, and society's expectations. Dear colleagues, the synthesis of science and art in the education of architects and designers is not a tribute to intellectual faction. It is a strategic imperative of our time. We live in an era of environmental threats, resource constraints, and technological revolution. Fragmented thinking is powerless here. Only a holistic view, only the ability to unite beauty and calculation, image and structure, will enable the future creators of our environment to respond to the most complex challenges of our time. Our task is to educate not narrow executors, but authors synthesizers capable of transforming architecture and design from tools for decorating the world into disciplines for its sustainable and meaningful transformation. Thank you for your attention.